Hello guys, welcome back to my channel. So in this video we are solving Leetcode question spiral matrix 3. So in this question we are given a matrix of size rows by columns and our starting point is R start and C start which is facing east. So in this matrix the northwest corner, that means this point, is the first row and column of the grid, and the southeast corner is the last row and column, that means this point. So what will we are doing is we are traveling in a clockwise spiral direction. So whenever we move outside the grid boundary, we continue our walk outside the grid. Okay. So we reach all the rows and column spaces of grid. So what we need to find is the all the coordinates which we are traveling inside the matrix. So we need to return an array or a two-dimensional array, which will be the output array, which consists of our all coordinates. So the number of coordinates will depend on the number of rows into columns. That means in the first example, we have one row and four columns. That means 4 into 1. So total number of coordinates will be 4. In the second example, we have number of rows as 5 and number of columns is 6. So that means we will have total of 30 corners. So one important thing we need to notice from the figure that after every second direction change, the number of steps which it is need to travel is also increasing. That we need to keep in mind. Okay. So our resultant array will have size rows into columns by 2. The second thing is steps will increase after every two directions change. To determine direction, let's assume the current point will be 0 0. So if we move right side, that means we are incrementing one column, that means 0 1. If we are going to the top part, that means we are incrementing one column, sorry, one row. So we will take the coordinate point as 1 0. If you are going to left side, that means we are decrementing one column, 0 minus 1. If we are going downwards, that means we are decrementing one column. So we will take minus 1 0. So we can create a direction array with the help of these coordinates. Direction array. So to move right side, we will use 0 1. It is right. Then to move to the top part, we'll use this 1 0 top part. Then we will go to the left side. That means 0 minus 1. Left side. Then for moving downwards, we'll use minus 1 0 downwards. So with the help of this direction array, we can determine the path of the points which we are traveling through the matrix. So now we can go into the coding part. So our result matrix in result equal to new in rows into column. Let the direction array VIRS equal to 0 1 1 0 0 minus 1. minus 1 0. This is for turning right, top, right, top, left and down. Let the index of the result be 0 at the beginning, index equal to 0. Then the direction arrays matrix PD is also equal to 0. So the number of steps at the beginning will be 0. While index is less than rows into columns. Then the first condition is if d equal to 0 or d equal to 2, steps will increase. Why? Because at the every two directions change, steps are increasing. Then we'll create a for loop for the steps for int k is equal to 0, k less than steps, k plus plus. If r start less than rows and r start greater than or equal to 0 and c start less than number of columns and c start greater than or equal to 0, then our result index plus plus. We need to increase the index also. New int r start c start. Then we need to update the r start and c start value also from the direction array plus or equal to dirs d, and we need the first index c start, not first index, zeroth index, sorry, c start plus or equal to dirs d1. Also we need to change the direction arrays index also. So d is equal to, after every loop, d is equal to d plus 1, but we need to take the modulus by 4, otherwise it will cause index out of bound. This 4 is actually the length of the direction array. So now we can return result. So let's run the program. Sorry. Okay, so it is accepted. Now we can submit the program. Okay. Okay, that's all. I hope you understood the problem. Thank you for watching. Please subscribe and like the video.